7.4 is moving on to something that's entirely different, and it's kind of its own little thing. It's called inverses of trigonometric functions. And really what I wish they titled this was, what would your calculator do? Or maybe, why does your calculator do what it's doing, right? That's sort of my wishing title of this, because it took me a long time to figure out why I was doing this. And I'm like, oh, they're proving to you why your calculator gives you the answer it does. Okay, so saying that, what we're going to look at is the difference between our original sine and cosine and tan functions and their inverses. So just to remind you, an inverse is found by reversing the x and the y values. In other words, your x-axis becomes your y-axis and your y-axis becomes your x-axis. Your domain becomes your range becomes your domain. Okay, so if we look at sine, this is its inverse graph, cosine and tan. Now, the next thing we want to look at is, are these inverse graphs functions? Well, if I look at them, to be a function, every x value can only have one y value. And if I look at this one, if I were to draw a vertical line, it would fail. So we know that these inverse graphs aren't functions. We could have told ourselves that right from the beginning, because we could have looked to see if the original functions were what we call one-to-one. One-to-one means that your original function passes a vertical line test and a horizontal line test. So the horizontal line test tests whether the inverse is a function. So all of these graphs pass the vertical line test, so we're all y equals cos x is a function, but they all fail the horizontal line test miserably. Okay, so what does that mean for us? Well, first off, we can answer this question. Are the graphs of sine, cosine, and tangent one-to-one? No. So are the inverse graphs functions? No. Well, who cares? Well, your calculator cares. So what the difference is that when we plug in y equals sine x, if I put in any value for x, like 30, right? So if I grab my calculator and I push sine of 30 degrees, I get 0.5, right? And there's only one answer I can get. Let's go, well, pi by 3, sure. That's pi by 6, so somewhere in here, right? If I plug in an x value of pi by 3, I'm only getting one y value. I'm getting 0.5, right? And that makes sense for your calculator. But if you were to do the same thing down here, and I was to put 0.5 into your calculator and say, ooh, okay, I want the reverse. So instead of saying that I'm saying y equals sine x, this time I've got the x over here. So your calculator needs to do something opposite. So the opposite of taking the sine of something is called taking the inverse sine of something. So this could also be written as y equals the inverse sine of x. And they've just chosen that. It's a way of telling your calculator, hey, I'm putting a ratio in here instead of an angle. So what angle would I get for that ratio? So in other words, if I were to put 0.5 in here and say, what is the inverse sine of 0.5? Without knowing what my calculator would actually give, right? It should give me this answer. 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 In fact, there's like an infinite number of answers it should give me. But that would blow my calculator's brain. So instead, what your calculator says is, hey, let's only look at a portion of each of these graphs. So you'll notice that each of these graphs has a purple section. And this is what your calculator focuses on. It says, let's restrict the range so that your domain will only give you one y value. So for sine, it restricts it. Now domain for these can only ever be negative one-to-one, because if you look back at your original graph, right, your graph only goes from negative one-to-one, right? So your range, which is now your domain for a sine graph, is always negative one-to-one. Same with cos. Okay. But it's the range that we're restricting. We're saying, okay, so for that domain, so for the x values, negative one-to-one, I'm only going to give you answers that are between negative pi by 2 and pi by 2. Now, it can't be identical for all the functions because cosine's a little bit different. So if I were to continue this graph like this, then actually this x value would still give me more than one y value. So they could either give you this section or this section. So they chose to give you the positive section, right? So they've restricted this range to between 0 and pi. That's a square bracket, not a round. Okay. Now tan doesn't have a restricted domain because it's that weird swoopy graph. So the domain is negative infinity to infinity. But we had to restrict the range as well, right? Because this cycle gets repeated over and over and over again. So your calculator just takes, or we are going to just take the one little swoop. And so it's also between negative pi by 2 and pi by 2, which is nice, right? So sine and tan are actually the same. All right. So let's look at down here. I often find it's more useful to look at the restricted ranges on a unit circle because that's what we're going to use when we actually evaluate inverse trig functions. So sine, we said that for every x value, we're only going to give answers between negative pi by 2 and pi by 2. For cosine, we said we're only going to give answers between 0 and pi. And for tan, it's going to be between negative pi by 2 and pi by 2. And I'm so used to only working in radians at this point. This calculator does like degrees. So we should also say negative 90 up to positive 90, and then 0 up to 180. And then this one as well, negative 90 degrees up to positive 90 degrees. Okay. So then what we want to do is we want to figure out how this is going to get used. So before I talk about that using inverse trig functions at the top there, I'm going to jump right to here. So what you're going to be asked to do is evaluate an inverse trig function. So these questions are going to stand out because they're not going to be written as y equals, sorry, that came out weird, y equals sine x, right? So the way that this would be written would be like root 2 over 2 equals sine x. This is a totally different question. This is going to be 7.5. Okay, in 7.4, they will specifically write it already as an inverse. That's when you know to give an answer in the restricted range. Okay, so let's answer these guys. So I want to find the angle that will give me a ratio of root 2 over 2. So I know that if to get a positive ratio, if I was looking at cast, sine could give me a positive answer in quadrant 1 or quadrant 2. But because I've restricted the range of the inverse, I know to only give the answer in the first quadrant. So then what I do is I figure out what angle, right? So we're always talking about these special triangles. So this is the 1 over root 2. So it goes 1, 1, root 2. So what angle has a ratio of root 2 over 2 in my restricted range? Well, it's my 45 degrees, which in radians is pi by 4. Okay. If we did the same thing for the inverse sine of the negative ratio, this time, CAST, I'm looking to see where I could get a negative answer. Now I could get a negative answer for sine in here, or a negative answer for sine in here. So quadrant 3 or quadrant 4. But I know which answer to give because I have to give it in the restricted range. So I'm going to give this angle here. Now you'll notice it goes down to negative pi by 2. So we are reading this angle clockwise, which makes it negative pi by 4. That came out really messy, sorry. It's hard to write in a small space on the computer. There we go. So my answer in degrees would be negative 45 degrees, and in radians would be negative pi by 4. Now before we move on to the next one, I just want to jump to the calculator. So again, all we're doing here is teaching you what answers your calculator gives, because your calculator will only answer functional answers, things where there's one response. So if I were to touch my calculator and I were to plug in inverse sine. Okay, I thought I would actually grab a graphing calculator to help you with this. So what we're going to do is we're going to plug in inverse sine. So an inverse sine, on your calculator will hit second function, and for me I did function, but we want to get that inverse sine. And then we want to do it of root 2 divided by 2. Okay, now my calculator does this automatically for me, but you can see over here, my answer in degrees is 45 degrees. So it gave me the answer I expected. I wanted to get the angle for this inverse sine of root 2 over 2 as 45 degrees. Okay, what about in radians? So hopefully you guys are all comfortable putting your calculator in radians. So for me, I just have to flip a switch. So to put it in radians to 4 decimal places, it would be 0.785 5, and then because the 3 is beside a 9, it'll be 4. So decimal 7854. So I'm going to put that over here. Theta equals 0.7854. And then what we want to do is plug in the exact same thing again, but we want to put the negative in there. So we go back in here. Now my calculator will allow me to just go in here and put a negative, which is kind of nice. Where's their positive and negative signs? I want to make this negative, 1 sec. Okay, sorry, I hadn't used this before. So to put a negative sign, I was allowed to just put the subtraction sign, which is super, which was super bizarre. So I could just put the negative sign in here. So again, in radians, I got the same answer, but negative. Just like pi by 4 became negative pi by 4. And if I switch this to degrees, I get negative 45 degrees. So I got the answers that I was expecting. I got theta equals 45 for the positive ratio and negative 45 for the negative ratio. I got 0.7854 for the positive ratio and negative 0.7854 for the negative ratio. So now what I'd like you to do is pause the video and give this exact same thing a go. So I want you to do it by hand first, and then I want you to check them with a calculator for your inverse cos. Okay, so hopefully you left and you're coming back. So where could I get answers for cos? Well, cos is positive in quadrants 1 and 4. So this is why they couldn't restrict the domain the same for cosine as they did for tan and sine, because if we went negative pi by 2 to pi by 2, we're only getting our positive answers. So the restricted range for cosine is between 0 and pi. So this is the answer I'm going to give. In fact, every positive ratio will give its answer in the first quadrant because everything is positive in the first quadrant. Okay, so what is the angle? Well, our ratio is 1 over 2, so the adjacent is 1, the hypotenuse is 2, so it makes my 1, 2, root 3 triangle. So we have to figure out the angle in degrees and the angle in radians. So it is across from root 3 is pi by 3. I work better in radians at this point because most textbooks switch to radians at this point, but this textbook's keeping both. So it's 60 degrees or pi by 3. So then if we did the same thing for the negative ratio, we know it's the same reference angle. It's just which quadrant do I give it in? Well, cosine is negative in quadrants 3 and 4. So the only one that's in the restricted range is the one in quadrant 2. So my answer would be, again, adjacent is 1, hypotenuse is 2, root 3. This would be a negative 1. Okay, so my angle, if my reference angle is 60 degrees, then the angle in the second quadrant is 180 minus 60, which is 120 degrees. And then if I was to do it in radians, it would be pi, which is 3 pi by 3, minus pi by 3, which gives you 2 pi by 3. Okay, so let's check that with my calculator. So if I was to check that in my calculator, I won't bring up that Desmos one again. I'm just going to plug it in. So I'm going to plug in my calculator in degrees. I'm going to say inverse cos of 1 divided by 2, or 1/2, which gives me 60 degrees, which was what I was expecting. So theta equals 60 degrees. And then if I switch my calculator to radians, and I hit equal again, I get theta equals 1.047. Does that make sense? Yes, it does. 1.0472. I was checking. I was like, pi is 3.14 divided by 3. Yep, that should work. So don't forget that that is what we're getting. We're getting pi by 3 as a decimal. All right, and then if we did the same thing with the negative case, I'm hoping that I get theta equaling, okay, in radians, because my calculator was in radians, is 2.0944. And in degrees, let me just switch to degrees. I get 120 degrees. Yay, they match. Okay, so hopefully you've been proved that all we're doing is giving you the answers that your calculator would give. Why does it give it those answers? Oh, so that it has a functional answer. And now you know which where we should expect to get our answers when our calculator does it. So what I want to do now is take it one step further. So the ones that your calculator can do are sine, cosine, and tan. So what happens if it gives you secant, right? How do I possibly answer something that's the inverse secant of 2? Well, you have to learn a skill first. The skill is that these are already written in inverse notation. So technically, they would have started, so if I look at this guy, it would have started with x equals cosecant y, right? That would eventually get y is the inverse cosecant of x. So if I switched it here, I would get the 1 over the sine of y equals x, and then I can flip both fractions or multiply both sides by sine y, but I get sine y equals x. So now if I want to get y by itself, sorry, 1 over x. I should go slower. So if I multiply both sides by sine x, I get sine x equals 1, or sine y equals x times sine y equals 1, and then I get sine y equals 1 over x. Okay, so then if I was solving for y would be the inverse sine of 1 over x. So this is just an important thing to remember. So it's not like switching your reciprocal functions when it's not in inverse, where you just go 1 over the entire trig function. Instead, it's 1 over the ratio. So if I had secant, the inverse secant of x, that would be equal to, so cos is the reciprocal function, the inverse cos of just 1 over x. Okay, what would you get for this one? Okay, hopefully you're getting, oops, the inverse function, reciprocal function of cotan is tan to the negative 1 of 1 over x. Okay, so then what's this question asking you for? This question is asking you for the inverse of cos of a half, which is one that we already did over here. So I'm just going to say that theta would equal 60 degrees and theta would equal to pi by 3. Okay, but we should draw them all out. I was just trying to be easy on you. Okay, next part. So let's just explore that what would your calculator do thing. So if I just plug in the inverse tan, now radians and degrees, so my calculator is in degrees. So inverse tan of negative 1.265. Before you hit equals, I want to think about where I'm expecting my answer. Okay, my restricted range is from negative pi by 2, or negative 90, up to 90. So because this is negative, my answer should be here. So when I hit equals, I get theta is negative 52 degrees to the nearest degree. Okay, and then all we do is we switch our calculator to radians, hit equals again, and I get negative 0.9019. All right, then we're gonna do the same thing for cotan. So first thing I have to do is change it to an inverse tan function. So 1 divided by negative 1.265, and then I plug that in. So I'm going to plug in the inverse tan of bracket negative 1 divided by 1.265, or 1 divided by negative 1.265, doesn't matter. Okay, so in radians, I get negative 0.6689, and degrees, I get negative 38 degrees. Okay, so totally different answer, but in that expected quadrant. So there's a quick check. Go and give these a go.